and today we'll be discussing and explaining how to find a definite integral for a piecewise function. So a function that's represented by more than one function across different domains. So to start off, I like to find a general procedure, and usually you could do a few examples and then find a general procedure, but as this is a visual kind of explanation, I'll give you first the procedure and then you can apply it to different examples. And this procedure is pretty logical, so you can find it intuitively. So when you have a piecewise function, it's made up of two or more different functions. You have f of x, and it's equal to, let's say, h of x for x is greater than a, and then g of x for x is less than a. That's the most simplest one. And to integrate this, we would want to, and for a definite integral, let's say we have a part, we want an integral that goes from c to b, and c is less than a is less than b. Alright? So to do this, we would want to first find the integral for each part of the function. So first we would find the integral for h of x, and then we would find the integral for g of x. Doesn't matter in which order, obviously. Then we would split our piecewise function, its definite integral, accordingly, so into different parts. And this is why I split it up over here. Let's say that x is equal to g of x at a. Okay, so now we can split the function into the different integrals. So we know that we're going to start off with c because it's the smallest, and we're going to go up to a, and then a will be g of x dx. Then we're going to have a second integral for the second part of the function, which is going to start from a and go into b, and it's going to be h of x. And our last final step is simply to actually integrate them and to add them together. Because if you can imagine, well, I don't know what these functions are, but for example, we have this and then we go like this. Who knows? Here we find the first part of the function, and then here is the second part. First, and then here's the second part over here. And first we integrate this part, and then we integrate this part, and then we have to add them all together in order to go from, for example, c to b if this is our a. So I hope this makes sense, and now we can apply it to a few different examples. Alright, so our first example is going to be when f of x is equal to x squared plus 5x when x is less than or equal to 4, and it's equal to 5 times e to the power of x when x is greater than 4. And we want to find the definite integral for f of x in between 2 and 6. Alright, so to start off, let's quickly rewrite this as a sum of integrals. So over here, let's start off with 2 going up to 4, and this is when x is less than 4, so it's going to be x squared plus 5x dx plus the integral going from 4 to 6 of 5ex dx. And now we just solve this. So over here we can utilize the power rule. So we have x cubed over 3. Sorry, this is a 5x. X cubed over 3 plus 5x squared over 2. And this ranges from 4 to 2. Plus, and over here we have 5 times e to the x, which is just going to stay 5 times e to the x in between 6 and 4. Alright, so now to do this, as this is a definite integral, we're going to find each of these parts and subtract the higher value from the lower value, and then we add them together. So first we're going to insert 4. So we're going to have 4 to the power of 3, 4 cubed, divided by 3, plus 5 over 2 times 4 squared, so times 16. And as a fraction form, that's going to give us 184 over 3. And now we repeat that same process, but with a 2. So we're going to have 2 cubed over 3 plus 5 over 2 times 2 squared. So we're going to have minus 38 over 3. And then we're going to repeat that with the other side. We're going to have 5e to the power of 6 minus 5e to the power of 4. And to simplify our fraction that we had over here, we have to just, it's already the common denominator. So we're going to end up getting 146 over 3 plus 5e to the power of 6 minus 5e to the power of 4. And we can't really do much more. I guess we can factor out the 5, so we can have 146 over 3 plus 5 e to the power of 6 minus e to the power of 4. But this is the exactest form. You can calculate the e and find out what it's roughly equal to. If I do that right now, that's going to equal around, and this is an approximation, 1,792.8199, etc. So this is our final answer for the first example. Let's move on to the second example. And I encourage you to try these by yourself, and then you can come back, because that's how you learn. So the second example, we're going to have f of x, and it's going to equal the absolute value of 3x plus 3. And although this is not written as a piecewise function, we can definitely rewrite it as one, because the way that you have an absolute value is that you always have the positive value. So here we can rewrite it for when x is less than negative 1, we have a 3x plus 3. For x is less than negative 1. And then for x is greater or equal to negative 1, we have 3x plus 3. So we rewrite this as a piecewise function in order to get the integral, and the integral we're going to get is going to be from negative 3 to 1. So over here, we can rewrite this as ranging from negative 3 to negative 1. We're going to have negative 3x plus 3 dx plus, ranging from negative 1 to 1, 3x plus 3 dx. Alright, so once again, we're going to integrate each part. So over here, and these are pretty simple, these are just power rules. Over here we're going to have negative 3x squared over 2, and then I just carry out the negative sign. Negative 3x to the power 1 over 1, okay, that's just x, plus, oh, and this is from ranging from negative 3 to negative 1, plus, here we have everything the same, just without the negatives. We have 3x squared over 2 plus 3x, and this ranges from negative 1 to 1. And once again, we just solve. So for the first part, we have negative 3 over 2 times negative 1 squared. That's just 1. So we're going to have negative 3 over 2 plus 3, because we're going to have minus 3 plus 3. And that's going to be 1.5. And then for negative 3, we're going to have negative 3 times negative 3 squared, so 9 over 2, which is going to give us negative 13.5, minus 3 times negative 3 plus 9. So negative 13.5 plus 9, that's 4.5. So we're going to have plus 4.5 because we're going to minus negative 4.5, which is going to give us a positive 4.5. So we're going to have 1.5 plus 4.5, and then to that we're going to add the definite integral of the other thing. So we're going to have, first we're going to have 3 over 2 times 1 squared. Okay, 3 over 2 plus 3, and that's going to give us 4.5. And from that we're going to subtract, once again, 3 over 2, but now we're going to actually subtract the 3. So in the end, we're going to end up having negative, once again, negative 1.5. So we're going to add the 1.5. And what we end up with is 1.5 plus 4.5 plus 4.5 plus 1.5. And this is just 6 plus 6. And what that gets us is 12. So our final answer is going to be 12. And this is the definite integral of this function, ranging between negative 3 and 1. Alright, so I hope you enjoyed and I hope you found this helpful. And I hope you understand how this works a bit better now. And always refer back to here. And thank you for watching.